Hello physics students, it's Mr. Kennedy. I hope everybody's doing well. I'm going to take you through a couple basic concepts here. The first one being momentum and the second one being impulse and how to look at some problems involving them. So I got my whiteboard here just like I would have in the classroom. As always, if you feel you have questions, feel free to email me, text me, or we can even set up a Zoom meeting if we need to. But the first concept we're going to talk about today is momentum. And momentum is how difficult it is to stop an object. That's really what it is, how difficult it is to stop. And momentum we define as mass times velocity. So what that means is objects that are really massive and are moving really fast are difficult to stop. Objects that are not very massive and moving very slowly are easy to stop. So just to give you a quick example here, or a couple examples, if I have a momentum of, let's say, a bicycle moving at, of 20 kilogram bicycle moving at 1 meter per second, this gives me a momentum of 20 kilogram meters per second. And there's no special unit for momentum, so it's just kilograms, which is the unit for mass, times meters per second. Also, because we've already used m for mass, p is what we use for momentum. We're running out of letters at this point in the year. So this would have a momentum of 20 kilogram meters per second. But let's say I took a 1 kilogram weight like we'd have in the classroom and throw it at 20 meters per second, throw it pretty hard at 20 meters per second. This would also have momentum of 20 kilogram meters per second. So these two things would have the same momentum. They'd be the same difficulty to stop. But this one is a really massive object moving slowly, and this one is a less massive object moving very quickly. So these two things can be compared in how difficult they are to stop. If I were to take, let's say a 1,000 kilogram truck moving at, let's say, 10 meters per second, now because that's massive and it's moving relatively quickly, this would then have 10,000 kilogram meters per second. So this would be much harder to stop than either one of those two things. And again, that's really what momentum is. Now the English language overuses this concept a little bit. What it talks about is, someone's campaign was really hard to stop, or this team was really hard to stop. So each one of them had a lot of momentum behind them. And they overuse it a little bit, but there is a technical definition to momentum, and that is, again, the mass times velocity of something. Something that's really massive and has a lot of velocity has a lot of momentum attached to it. But how do you change momentum? And that's where we get into the idea of impulse. So momentum is just the mass times velocity, but impulse is how much you're able to change that momentum. And let's take a little box here. Got a little box. And if I take this box and push it with a force, that doesn't necessarily do anything. I can't just give it a push without doing something else. I have to push it for a given amount of time. I got to push it for a little while to change what it's doing. So this concept of impulse has two parts to it. It has a force and it has a time attached to it. So you can't just push something for an instant. The longer you push it, the more you're going to change the object's momentum. This particular box's momentum. Now in sports, typically this concept is called follow-through. For instance, if you have ever played baseball, softball, golf, tennis, anything like that where one object is going to hit another, you're trying to keep the objects in contact for as long as possible. For instance, in baseball, you could only swing the bat so hard to make the ball move either in a different direction or to make it move faster. What you're going to have to do is apply it for a long time. So the longer you keep the bat and ball in contact, the more you're going to apply an impulse to the object. But let's look carefully at what impulse actually gives us. It's force times time, but force is ma. An unbalanced force is ma times time, but A is v final minus v initial over time multiplied by time. And what we see here is the time cancels, and then we get this. This is mv final minus mv initial. So this is my final momentum, and this is my initial momentum. So what's amazing about this is force times time really is a change in momentum. This is a huge equation for us. It's one of the big equations that we're going to have in this unit, is that force times time is the same thing as change in momentum. I'm going to rewrite that for you here in a minute, but I actually used to give test questions where I would say, part A, find the impulse. Part B, find the change in momentum. And the trick to it was they were the same thing, that this and this are the same thing. Now, some people write this in this way. This is the way I prefer. Force times time equals mv final minus mv initial. Some people like it like that. Some people just say force times change in time is change momentum, but this is the one I like the best. Force times time equals mv final minus mv initial, because everything's right there and you can just plug it in. So we've really had two big equations so far. The first one is that momentum is just mass times velocity. And the second one is that force times time is equal to the change in momentum. This is impulse, this is change in momentum. They're the exact same thing. As a matter of fact, you might remember that I didn't like the idea of work when we did energy. I just thought we should have called it change in energy. I don't like the idea of impulse either. I don't like it giving it another name. I just think we should call it change in momentum. So let's take a look at an actual example with this, and we'll see how to use this equation. Now, I recommend that when you do problems, I would draw a picture. Draw a picture of what's happening, because it'll be much easier to see that way. So let's say we have a baseball. Here's a little baseball. And this baseball is 0.15 kilograms, moving at 20 meters per second. And it's hit by a baseball bat. There's the baseball bat there. It's hit by a baseball bat, and the baseball bat and the ball are in contact for a time. They're in contact for a time of 0.01 seconds. So not a very long amount of time. And what happens is the baseball gets hit back out at 20 meters per second. So it comes in at 20 meters per second, gets hit by the baseball bat, comes out with 20 meters per second. Now, one of the problems that you may have here is that momentum is a vector. It has a magnitude and direction, so you have to be very clear about which way is positive and which way is negative when you're solving these problems. Otherwise, things are not going to work out. So what I recommend, once you've drawn a picture of what you have, right underneath that picture, draw a label of which way is positive and which way is negative. It doesn't matter which way you call positive and negative, but you just have to be consistent. So I'm going to call this way positive and this way negative. Now, what I'd like to find in this situation is how much force did the bat exert on this ball to change it from this momentum to this momentum. So let's see what we have here. We can look at force times time equals mv final minus mv initial. We are looking for the force. That's what we're looking for. How hard did the bat hit the ball? So the force times 0.01, that's how long they were in contact. Now, let's look at this. This is m, the mass of the ball, times v final. Well, this is the final velocity. And since it's going this way, it has to be negative. So this is 0.15 kilograms times negative 20 meters per second, because it's going this way, minus, that's this minus right here, this initial velocity was this direction to the right, so it's got to be positive. So minus 0.15 kilograms times positive 20 meters per second. Now, the number one mistake that students make with this is they assume that this negative is taking into account this negative. It doesn't. This is always here. You have to put in the parentheses what you'd want the negative sign to be there. So, what do we have then? Well, force times 0.01 seconds, 0.15 times negative 20, that's going to be negative 3 kilogram meters per second. 0.15 times 2, that's 0.3, and then multiply by 10, so that's going to be 3. And then minus 0.15 times 20, that's minus 3 kilogram meters per second again. So when we look at this, what happened was I had a momentum of positive 3, and then I had a momentum of, when I came back out, of negative 3. So if I'm going from positive 3 to negative 3, that's a change of negative 6. Because I was at negative 3, or I was at positive 3, and then I moved to negative 3. That's a change. I went 6 places toward the negative. So that means force times 0.01 seconds is equal to negative 6 kilogram meters per second. So the force, because this is 1/100th, is going to be negative 600 newtons. Now, what's really important about this is this negative sign is in there, because when the bat hit the ball going this direction, which is negative, so it works out. Had I rearranged it all, it would have been the exact same. So be careful with your signs in this. Set up the equation and you'll be all set. So what you learned so far was that momentum, mass times velocity, is how difficult it is to stop something. Impulse is what happens when you change the momentum, and this is your big impulse equation here. And you need to be careful with your signs. Draw a picture, give yourself a little indication of which way is positive, which way is negative, stay organized, and you'll be just fine. So as always, feel free to email me, text me, or if you need to set up a Zoom meeting, we can do that. But I want to hear from you, see what questions you have, so you can learn momentum and do really well with it. All right, everybody, have a great day.